Alright, so today we're working on lesson 1.3, which is on solving linear equations. And we talk about solving linear equations. One of the things that I like to continually go back to when we're solving equations is this idea that an equation is a statement that two expressions are equal. And so those expressions might be variable expressions. One of them might be a constant. So for example, something like 3x plus 2 is equal to 5. That's a variable. It has a variable expression, which is the 3x, and again, it has a constant expression on the other side, which is a 2. But again, in a statement that two expressions are equal, again, we just have an equal sign. I like to think about that as a teeter-totter, a balance. Okay, so going back to our elementary days, we have a teeter-totter in the playground. You and your friend get on the teeter-totter, and it's again, you balance. If your weight is exactly equal, you'll balance, or will be equal to each other. So the idea that we think about this as a balance says that, look, if I do something to one side, I have to do to the other, and that keeps things balanced. We'll get more into that as we talk about equivalent equations. But for right now, as I start to talk about this, if I draw my picture of a teeter-totter, understand where I'm kind of going with that, okay? A linear equation is one that has a variable, basically. And again, linear, meaning that x can only be raised to the first power. As we get into things like x squared, those are called quadratics, all right? And x to the third are things called cubics. We will be dealing with those sometime during Algebra 1A, but not necessarily anything right away. So this kind of stuff doesn't fly right now. Again, linear equations have your variable to the first power. And it doesn't always have to be x, but again, our variables to the first power. A solution is a number that when I plug it in, it satisfies the original statement or it makes a true statement. So for example, our one from before, 3x plus 2 is equal to 5, you would find that x equals 1 is a solution because 3 times 1 plus 2 is equal to 5. And so x equals 1 is a solution, and we're going to talk more about how you actually find those solutions to much more complicated problems as we go. And again, this should be review for many of you, being that this is now Algebra 2. But again, not a bad idea to go over this. So equivalent equations are two equations that are equivalent. And again, they're equivalent if they have the same solution. So if x equals 1 is a solution to one equation, and x equals 1 is a solution to another equation, then those two equations are said to be equivalent. Okay? All right. We talk a little bit about this idea of transformations. And these transformations are things that we do to both sides of an equation. So first of all, the addition property of equality. Addition property of equality says, look, if you add the same number to each side of an equation, then you produce what's called an equivalent equation. So again, if I add, x minus 2 is equal to 4, and I added 2 to both sides of this equation, that would produce the equation x equals 6. And so x equals 6 is a solution to this equation, obviously, because if 6 minus 2 is 4, and 6 is obviously a solution to this equation because 6 is equal to 6. All right, we'll get into more complicated examples shortly. But as long as you add the same thing to both sides, you are using what's called the addition property of equality, and you're producing an equivalent equation. Same is true for the subtraction property of equality. If you subtract the same thing from both sides of an equation, you produce an equivalent equation. Multiplication property of equality says if you multiply both sides of an equation by the exact same number, you get an equivalent equation. And finally, division property of equality says the same. All right? So going back to my teeter-totter example, and these two individuals are completely balanced. And this is the best artwork you're going to get from me, guys. These two individuals are completely balanced. If this person were to add 25 pounds to their weight, in order to keep this thing balanced, then this person would have to add 25 pounds to their weight. And so that would produce an equivalent equation. If this person were to find a way to miraculously lose 25 pounds, then this person could lose 25 pounds and they would still remain balanced. By the way, let me know that weight loss routine. I would be certainly interested in that. All right, so multiplication property of equality again says the same thing. If I were to double both people's weight, they'd still balance. If I divide them both by 2 or any other number for that example, they would still be equivalent. So let's just jump into an example here. First thing we're going to do is we're going to solve an equation with a variable on one side. So we have 3/4 x plus 15 is equal to 33. And so if we go back to that idea of this thing balancing, in order to get rid of adding 15, we're going to subtract 15 from both sides of my equation. If I subtract 15 from here, I get 3/4 x is equal to, and this should be equal to 18. All right? And so now what we have then is we have 3/4 times x equals 18. Just be careful with this because we don't divide. Again, to get rid of multiplying by 3/4, we don't divide by fractions because dividing by fractions can lead to something a little bit screwy, especially as you're looking at something like this. So what we do instead then is we say, look, what we would like to do is we would like to get rid of the 3/4 so I can just get 1x all by itself. So we're actually going to employ the multiplication property of equality. We're going to multiply both sides by 4/3. Say, well, why am I choosing 4/3 and why in the heck am I multiplying? Well, 4/3 times 3/4 becomes 12 over 12. 12 divided by 12 is just 1. So I get 1x, which is exactly what I want. On the other side of this, you can multiply first, then divide by 3. I prefer to reduce first. 3 goes into 18 6 times, and 6 times 4 is 24. And so x is equal to 24. Now, this is not in there, but as you look at your instructions for the next two checkpoint problems, you'll see that it says check your solution. So we should always check our solution. And we're going to do it the easiest way we can. 3/4 times 24 plus 15. What I would do is I would plug this into my calculator because if you have 3/4 in your pocket, you have 75 cents. So I would put 0.75 times 24. And if I plug 0.75 times 24 in my calculator, I get 18. And 18 plus 15 is equal to 33. So my answer checks. All right? You are guaranteed that you know your solution is 24 because you have went back and plugged that in and evaluated it again to make sure that it works. Okay? All right, so you've got two checkpoint problems now. I'd like you guys to pause your video and I'd like you to try these two examples and then you may restart the video and check your solutions in just a moment here. Okay, so we're trying to get this 15a by itself so that we can use the division property of equality to get rid of times 15. In order to get rid of subtracting 6, the first thing we have to do is add 6 to both sides. And so this is 15a is equal to 15. And then we're just going to divide both sides by 15 because, again, to get rid of multiplying by 15, we have to divide by 15. And a is equal to 1. To check my solution, 15 times 1 minus 6 is supposed to be equal to 9. And is that equal? Well, 15 times 1 is 15, and 15 minus 6 is in fact equal to 9. And so my answer checks. Another one of these with the fractional problems. Again, we're going to get rid of multiplying by 5 6 at the end of this thing. So we have to get rid of this plus 3. So I'm going to minus 3 from both sides. Another way to think about that is adding the opposite, which is adding negative 3. Again, negative 3 and positive 3 will cancel each other out. Again, whichever way you like it is fine with me. And 13 minus 3, or plus a negative 3, becomes 10. We then multiply both sides by 6/5. And again, we're going to make this 10 over 1. 6/5 times 5 6, well, that's hard to say, cancels each other out, and you're left with y is equal to, and again, you could do this as 60 over 5. Again, multiply, when you multiply fractions, you multiply tops and bottoms. 60 over 5 reduced is 12. The other thing you can do is you can say, look, 5 goes into 5 once, 5 goes into 10 twice, and 2 times 6 is 12. So whichever way you like is just fine. All right. So our last piece of this lesson then is solving equations using the distributive property. And so if we take a look at solving equations using the distributive property, again, our original equation is this mess here. So we're going to distribute, and we're going to distribute. And so again, when you're distributing, you're dropping off. It's like your teacher asks you to distribute these papers. Well, you're distributing one. You're giving one to everybody in the class. Well, here's your class, and everybody gets one. Okay, so this is 3 times 3x, which is 9x. 3 times negative 2. And again, remember we talked in the first lesson about changing that, subtract the plus a negative. Might make it a little bit easier when you distribute. 3 times negative 2 is negative 6. So you can have this as plus a negative 6, or you can have it as minus 6, whichever is fine. Again, 7 times 4x is 28x. 7 times 3 is 21, minus 31x. Now on the right side of this equation, before we start to solve, we have to combine like terms. We've talked about that in the previous lesson, but you have to combine like terms, and so we want to try to put those terms together that are the same terms on one side of the equation before we start moving things around from one side of my teeter-totter to the other, right? So if we can simplify this side of this mess prior to then it might make our life a little bit easier. All right? So this becomes 9x minus 6 equals, and on the other side of this thing, 28x minus 31x becomes negative 3x, and you still have your positive 21. Continue with the same idea of keeping things balanced. All right? We need to get all of our x's on one side of the equation. You can't just grab negative 3x and throw it on the other side, because that's not going to keep things balanced. Instead, to eliminate the negative 3x, I'm going to add 3x to both sides of my equation. Negative 3x and positive 3x are going to cancel, and this gives you 12x minus 6 is equal to 21. From there, you're going to add 6 to both sides, because again, we've got this 12x isolated. Okay, we want to get it all by itself so we can divide by the 12 and get x by itself. So we've got to get rid of minus 6, which is adding 6. So you get 12x is equal to 27. And our last step is to divide both sides by 12. And listen, don't let fractions freak you out, okay? You're going to see a lot of fractions in this particular course. These are both numbers that are divisible by 3. 3 goes into 27 9 times, and 3 goes into 12 4 times. And so 9/4 is the answer as a rational number, as a fraction. If you did 27 divided by 12, you may have also gotten 2.25. And that would be perfectly acceptable as well. Okay? So I'm going to let you pause the video and try the last couple examples here on your own. After you've tried the 2 examples, you may go ahead and resume the video and take a look at the solutions and see how you did. Okay, so if you've given this a shot, you should be seeing that we distribute. This becomes 4x minus 24 is equal to 3x plus 6. We need to gather all our x's on one side of our equals, but we can't just drop it over on the other side because we have to remember our teeter-totter here, right? So we're going to get rid of, we can get rid of positive 4x by minusing 4x, all right? Or we can get rid of 3x by subtracting 3x. All right, you have a choice. You can do anything you want. I'm just going to choose to subtract 3x from both sides with the idea that that is going to give me 1x, and it's positive, and I sure like positive variables much more than I like negative ones. The negative 24 doesn't change. That just comes down. The 6 doesn't change. That just comes down. We still got our equal sign, but over here, 4x minus 3x becomes 1x. So we're going to add 24 to both sides. And in this one, we get 1x is equal to 30. Now, don't take the time to do this, folks. Okay? 1x is the same exact thing as just an x, and so x is equal to 30. And so there's where you are. Okay? And the next one, go ahead and distribute. 3x plus 12 is equal to negative 2 times x is negative 2x. Now, I've got to be careful here because this is negative 2 being distributed to negative 7. So negative times a negative becomes positive. Let's see if I can write a plus sign instead. Negative 2 times negative 7 becomes positive 14, and you still have this minus 15x on the end. Combining like terms, negative 2x and negative 15x becomes negative 17x. So before I start jumping things on either side of this equal sign, I'm going to want to simplify this side of the equation first. All right? So this becomes 3x plus 12 is equal to, and negative 2x minus 15 more becomes negative 17x plus 14. Now, as I said before, you've got a choice here. You can either subtract 3x from both sides, or you can add 17x to both sides, whichever one you choose to do. If I choose to subtract 3x from both sides, I'm going to end up with a negative variable, which is okay, but sometimes negative variables can get a little bit more messy, especially as we start getting into solving inequalities. So I'm going to choose to add 17x to both sides, and I apologize for running out of space here, so I'm going to move this up over here. So 3x plus 17x becomes 20x, plus 12 is equal to 14. And from there, we're going to minus 12 from both sides. And so I get 20x is equal to 2. All right? Divide both sides by 20. And x is equal to both even, right? So they both divide by 2. And so this is 1/10. And again, you can plug that back in and check, or you can just take my word for it. That should get you a good solution. All right. So again, if you plug that 1/10 back into your equation, you should get the correct answer. They should be equal to one another. I'm not going to take the time with that today. All right. So hopefully this lesson went well for you. And remember that a lot of this stuff is, sorry about that, all of this stuff should be review for you, but again, understand sometimes we forget some things. And so, again, hopefully this went well for you. Questions on the video, see us tomorrow, and we'll definitely go over some of your concerns.